Welcome to Calculus and Vectors exam review for Unit 2. Unit 2 was a big one. It was on derivatives. We learned a lot of big ideas that we used for a lot of the rest of the course. There's actually just a couple of little questions in here, and some of the other ideas that were important that came out of this unit are covered in other areas of the review. But a couple that were sort of exclusive to this unit will be covered here. First one is a chain rule question. It gives you y in terms of u and then u in terms of x. That's how I know it's going to be a chain rule. And if you recall, we have Leibniz's notation, which shows us this idea. So if dy by dx will equal dy by du times du by dx. So I can take the derivative of each of these separately with respect to the appropriate variable, and then just multiply them to get it overall. And this is one where it gives us the value, so we don't have to do any simplifying or anything like that because we have different kind of variables in, but we have the value of the variables. So then we can go ahead and actually evaluate the answer for dy by dx in this case. So the first thing we have to do is we're going to need dy by du and du by dx, and then we're going to end up multiplying them together to get dy by dx. So if y is equal to this, then I do dy by du equals, and this is quotient rule because it's got a variable on top and on bottom. Okay, so that is the derivative of the top, which is just -1, times the bottom, which is u plus 1, minus the derivative of the bottom, which is just 1, times the top, which is 5 minus u, all over the bottom squared. And I'm going to simplify this a little bit before we sub in. So I get negative u minus 1 minus 5u plus u. Sorry, minus 5 plus u over u plus 1 squared, and u minus u is gone, and I get negative 6 over u plus 1 squared. Okay, and then this is u in terms of x, so I can do du by dx, and this is like x plus the square root of x plus 3, right? But it's written out the way we actually want it. So we've done this a lot, but I take the exponent out front. Oops. Subtract 1 from the exponents, that becomes -1/2, and then multiply by the derivative of what's inside, which in this case is just 1, but just you can't forget to do that since this is review. I think it's a good thing to do. And then this is 6x to the -1. So when I bring the -1 out, I get -6x to the -2. Okay, and this might be one that when we are doing a lot of this, we can do in one step, but again, it's good to go back and review this properly. So this ends up being 1 over 2 root x plus 3 minus 6 over x squared. The only thing we have left to do, let's write this out. Therefore, dy by dx equals dy by du times du by dx, which is -6 over u plus 1 squared times 1 over, and there's no point in simplifying this, like I said, because we're subbing in and solving anyway. So now I've got an expression for dy by dx, but it's got u's and x's in it. We only have x, so we have to go and find u. And how do we do that? We just sub our x value in here. So if x is 1, I hope I have enough space to squeeze it in here. This is 1 plus 3 to the 1/2, so the square root of 4, which is 2, plus 6 over 1. So that looks like 2 plus 1, which is 8. Okay. So u is 8 and x is 1, and now I can sub these in. So this is 9 squared, obviously. So this is 6 over 81 times 2 times 1 over 4 minus 6. And this ends up being negative 6 over 81 times negative 23 over 4. And that should work out to 23 over 54. Positive. Okay, so the trick to this one is using Leibniz's notation and recognizing that we can come up with this expression. We got to solve for u, and then just taking the derivative of each of them separately and multiplying them. Next question. This one's one of those big ones where you have to differentiate and simplify fully. The only other time you have to do this is if you are solving. This is why we spent a lot of time on this, because we ended up solving for x-intercepts and where the derivative is 0 and all of that stuff. Where the second derivative is 0, looking at concavity when we started graphing, right? But at this point in time, we were just practicing the skill. So this is obviously product rule. We've got 1p times q. So one thing times another, they both have x in them. So how do we do product rule? To take the derivative of the first thing, that's the 4x squared minus 3 all squared. So I got 2 times 4x squared minus 3. Subtract 1 from the exponent to the 1. And then I also have to do times the derivative of what's inside, which is the derivative of this part, because that's just going to be 0. So that ends up being 8x. And then don't forget, this is an easy thing to forget. This is just a derivative of the first part times the second. But you don't do anything to the second. Plus derivative of the second part. So bring the 3 down. X squared plus 3 all squared times the derivative of what's inside. In this case, that's 2x, because that's just the derivative of x squared, times the first thing. Now, I'm going to clean this up a little bit. You might be able to start factoring at this point, depending on your comfort level. Whoops, that's the x. So I'm putting the monomials together. This also shows us what it would look like if we didn't have to simplify fully. You'd be required to put the monomials together. So 3 times 2x is 6x. But taking a step to do this helps make sure that we don't miss anything and we see the full common factor and do that in one step properly, okay? So now I'm factoring everything I can out of this first part and this second part. So we'll factor the monomials first. And all you can factor out of that is 2x. And this is where, with a little bit of practice and experience, we start to realize with a little bit of experience, you notice that there's always this first bracket. There's, you know, 1 or 2 of them, or 3 of them, or 4 of them, however many, in each part, and then same with this, right? So you're always factoring out some of this bracket that came out in some of this one. So 4x squared minus 3, and that's the only one we can factor out. So we got 2 there, but only 1 here. And in this case, we can do 2 here, because we've got 2 there, and 3 there, but only 2 there. So x squared plus 3 all squared. Then I get my big brackets and I see what's left. So this looks like 8. And I took all of this one out, but I got one of this one left. And that's kind of always the way it works out, right? That you end up with one of them left over. And this one looks like 3. And I factored out both of those, so I've got one of this left. So now all that's left is to expand and simplify that last big bracket. So we've got 8x squared plus 12x squared is 20x squared. And 24 minus 9 is 15. And technically we factor fully, so this has to be factored as well. So I can factor, I think, just the 5 out of there, and I'm going to take that and I'm going to multiply it through with the 2 over here. So this is going to become 10x and I factored a 5, so I've got 4x squared plus 3. Now that looks a lot like this bracket, but that doesn't matter. They're not the same. That one's minus, that one's plus, so we are done. That is differentiate and simplify fully. It's fully factored. One fraction, if that was applicable, it wasn't in this case. Monomials all put together. No negative exponents. We always look at those as well. Okay, so that's differentiate and simplify fully. Okay, we got one more example to do here, and this is where we are finding, in this case, we're finding the points on the curve. Sometimes we're finding the equation of a tangent line, but we're finding the points on the curve where the tangent line is parallel to this. Well, parallel to this means we have to determine the slope of this. And if you remember, that's a grade 9 thing, and we're going to do that by putting it in y equals mx plus b form. So I'm going to come over here and do this. I'm going to write it all out again. 4x minus y plus 1 equals 0. And I'm going to move the 4x and the 1 to the other side. And then divide everything by -1 to flip all the signs. So the slope of this is 4, and so a parallel slope is 4. If it was perpendicular, that would be another story. We'd have to take the negative reciprocal, but this one's just the same. So now we have to determine the derivative of this and set it equal to the slope, because when I do y prime, that is the slope of the tangent of this curve. So derivative of 7 is just 0, that's gone. Derivative of -8x is -8. And we already did this one. Derivative of something over x flips the sign. Oops. And then the x becomes x squared, because it's like multiplying by a -1, and then you square the bottom, right? Because you increase the exponent by 1. So I've got that. Now I can set it equal to 4. Add 8 to both sides, and now I'm just solving for x. This becomes 12. I'm moving the x squared over to the other side. Divide both sides by 12. And be careful, x equals plus or minus 1. So sometimes we get 2 points when we do this. So when x is negative, when we're supposed to find the points, not just the x values, so we have to find the y value, and to do that we sub back into the original equation. This is an expression for the tangent. If we want to find the actual y value, we have to use the original function. So this is 7 plus 8 plus 12, which is 27. And then at x equals +1, that's 7 minus 8 minus 12, which looks like -13. Therefore, the points are -127 and 1 and -13, where the slope of the tangent is 4, which is parallel to that line. So those are 3 questions just on derivatives. Like I said, I mean, this was a straightforward derivative kind of question where we did a lot of that, but we also did some implicit differentiation, some different things that have to do with derivatives, but those will come up in other areas of our review because we did touch on that in other units as well. But those are a couple of the other sort of tricky questions that we saw in that unit, didn't maybe see as much of in other areas.